Okay, so another example or another question discussed is this practice question 441. Please ignore the number of the question. We have a mass of 15 kg of air in a piston cylinder device. It's heated from 25 to 77 degrees by passing current through a resistance heater inside the cylinder. Pressure is constant, there's a heat loss. Determine the electric energy supplied in kilowatt hours. So this is almost exactly the same as the previous question. Okay, it's exactly the same. You have a piston cylinder, inside is air, but now it's even simpler. You have the mass. Remember, in the previous one, you had to calculate the mass. And you have T1 and T2. Very nice. T1 is 25. T2 is 77. How do you heat it up? By passing through current. So that's electrical work in. Okay, we don't have the values though. Now the pressure inside is constant, so P1 equals to P2 equals to 300 kPa, and there's a heat loss of 60 kilojoules, so Q out equals to 60 kilojoules. Determine the electric energy supplied. That means electric energy. So this is W E. So basically this is what you have to find. And in kilowatt hours, now kilowatt hours is just a unit. Okay, it's kilowatt hours is a measure of electrical energy. Okay, remember we always use kilojoules. So kilowatt hours is another unit. Okay, if you look at your electricity bills, you'll find kilowatt hours. Alright, so very similar to previous question. So first you have to write the equation. We have electrical work in, and then we have Q out, and then we have boundary work, always negative, equals to delta U, and then we move this to the other side. Electrical work in minus Q out equals to delta H. So this is what you want to find. You have this and you have mass H2 minus H1. You have mass H2 minus H1. Now, I put this here because you can use two ways to solve. One way, this is the second way. So you can challenge yourself. You can first find W in using this method, the first method. So just find H2 and H1. Okay, so ignore that this is internal energy. Okay, it doesn't matter because it's the same approach. Okay, so this is H equals to H2 minus H1. This is delta H Cp average times delta T. Okay, so I urge you to use both methods. And of course, the solution can be found here. Okay, both solutions can be found here. So this is this is general, and then this is using the first method. This is using the second method of using the specific heat. Okay, so take advantage of the solution that's already provided. You can pause and analyze this. Okay, of course, I have also uploaded this in the lecture notes part. Okay, now I want to talk a bit about kilowatt hours. The hours here could be misleading. As you know, kilowatts is the same as kilojoules per second. Right? Which means kilojoules is actually kilowatts times second. Okay, kilojoules is kilowatts times second. So kilowatt hours is actually kilowatts times hours. That's it. Okay, why our electricity bill is in kilowatt hours and not kilojoule? Because kilojoule measures electricity per second, which is a mess. You don't watch TV for 3,000 seconds. You measure it in hours or minutes, which could easily lead to hours, right? So that's why it's in kilowatt hours. It's kilowatts times. So the only difference between kilojoule and kilowatt hours is this portion, which means second to 3,000 to hour. 3,600 seconds equal to 1 hour. That's how you convert. Okay, so we'll discuss this when we meet if you have any questions left. All right, see you.